This video is the first of my three-part internship report for the company Cosmoreal. In this video, I'll be explaining what my project is, how I made it, and show the final results. Photogrammetry is the science of making measurements on photographs. The input of photogrammetry is photographs, and the output is typically a map, a drawing, a measurement, or a 3D model of some real-world object or scene. My project is to create a system that will make a dataset of images of an object and use photogrammetry to create a 3D model of the same. A big limitation for me was that I started this project in the middle of the coronavirus lockdown, because of which I had to make do with whatever parts I had at home, limiting the scale of the project. The first step to obtaining a good model is creating the dataset, which is also the hardest step. The dataset must contain images of the object kept at various angles, and depending upon the complexity of the object, may require 50 to a few hundred images. In order to obtain these images, I designed a system that uses a stationary camera and a rotating platform. The platform is mounted on top of the white wheel with the motor connected to the wheel in a gear-like arrangement. I connected the motor to the rotating platform indirectly in order to prevent excess strain on the motor in case something too heavy is placed on the platform. The system contains the following electronic components. Circuit diagram and code is in the description. The LCD, keypad, and I2C from the UI for the Arduino. The breadboard power supply acts as an adapter in order to be power supplied to a stepper motor from a laptop USB port. The stepper motor driver allows Arduino to control the stepper motor that is connected to a rotating platform. The IR LED is for triggering the camera to click a picture, and finally, the Arduino acts as a brain that is controlling the entire system. After assembly, this is what the setup looks like. As you can see, the object has been placed on top of the rotating platform. The rotating platform is being controlled by a stepper motor. The IR LED meant for triggering the system has been placed in front of one of the IR receptors of the camera. The IR LED is connected to the Arduino through a long wire. At the back, all the electronics have been connected. This is the Arduino microcontroller. That is a wire connected to the IR LED at the front of our setup. This is the breadboard power supply, keypad, LCD, LCD to I2C adapter. As you can see, the Arduino and the breadboard have been connected to my laptop through USB cables. This is purely to provide power supply. There is no data transfer occurring here. In order to operate a system, we have to first give it certain information. The first piece of information is the number of layers, which is the number of different heights the camera will be taking pictures from. Next, it asks for number of pictures, which is the number of pictures the camera will take per 360-degree rotation. Next, it asks for number of rounds, which is the total number of 360-degree rotations the camera will click for each layer. Now that I have inputted all the information, the camera should start clicking. The system is now asking me to change layer, which means it wants me to change the height and angle of the camera manually. I was unable to automate this part as I did not have a motor strong enough for handling the weight of the camera and was unable to acquire one due to being stuck in the middle of COVID crisis. I've already adjusted the height and angle of the camera, so now I can just press start and the camera will continue clicking. Now that the system has finished clicking all the pictures, we can move on to a next step, that is rendering. In order to render 3D models, I tried using two different photogrammetry softwares, Meshroom and Reality Capture. Meshroom is a free open source software based on the Alice Vision photogrammetry framework. It has a relatively simple and straightforward UI, and in my opinion, is the best among the free photogrammetry softwares available. However, the software is very aggressive in removing shadows and is not very good at handling reflections, making it unable to detect black objects or render black parts on objects. Moreover, every render fills up several GBs of disk space, with intermediate renders that need to be deleted manually after the final render is obtained. Reality Capture is currently the best photogrammetry software in the industry. It's able to process large data sets with less amount of system resources and is even able to give accurate 3D models with small data sets. However, the software comes at quite the price premium, require one to either pay for each individual render or purchase an expensive monthly subscription. This is also why all the models in a video are all previews. Now that I've obtained the 3D models, I can use them as 3D assets for games, virtual reality, augmented reality, and other such softwares. I would like to thank Mr. Himanshu Gupta for giving me this opportunity to intern with this company, Cosmoreal. Cosmoreal is an AR-based startup that uses AR to help in interior designing. Link to company website is in the description.